Alright, so in this configuration, I'm in the xy plane. I have two charges of positive q, both on the y-axis, one at plus d and one at minus d. Three questions to answer. What is the potential at the origin? What is the potential along the x-axis? And what is the potential anywhere on the xy plane except for at the charges, because the potential tends to blow up over there. For the first part of this problem, before we continue, we have a discrete set of charges. So instead of using the integral definition of voltage or electric potential, I'm going to use this definition here, where the electric potential is the summation, or 1 over 4 pi epsilon naught times the summation of the individual charges over their distances from whatever that position is. So for part A, the voltage is just going to be 1 over 4 pi epsilon naught times, so from this origin, this q over whatever this distance is, and this distance is going to be d. So it's going to be q over d, plus this charge q over the distance d. It's not going to be negative d. It is just going to be the absolute value of the distance, the actual length. So it's going to be q over d again, which gives me 1 over 4 pi epsilon naught times 2q over d. Alright, so for the second part, just find the potential along the x-axis. So, I'm going to pick a random point on this axis. Okay? It's going to have some distance x here. And as always, it's still going to be d vertically from either charge, which means that the distance here and the distance here is going to be the same at the square root of x squared plus d squared for either of these. This will be the r that we use in this formula. And since it's identical, I'm just going to add that twice. The voltage for this part is going to be 1 over 4 pi epsilon naught times 2q over square root of x squared plus d squared. Alright, so for the third part, we're just going to find the potential anywhere on the xy plane, say for these 2 points. So any point on the xy plane is going to have position x, comma, y. So for instance, the x position is always going to be x relative to both of these charges. But for one of the charges, it's always going to be d plus y, and for the other charge, it's always going to be d minus y, assuming that this distance right here is going to be y. Now, whether it's the upper charge that has d minus y or the lower charge that has d minus y, it really doesn't matter, because the potential is going to be the same for either of those points. This means that the potential is going to be 1 over 4 pi epsilon naught times q over the square root of x squared plus d minus y squared plus q over the square root of x squared plus d plus y squared.